Okay, so I know it's been a while. We did learn derivatives of inverse functions, and the main thing we learned from that is the derivative of the inverse of f is 1 over f prime of f inverse of whatever the number we're looking at. Okay, so it's been a while, so I'm going to go over a review real quick of the lesson that we did a long time ago. This is from a very, very long time ago. Okay, so if you have it in your notebook, which a lot of you do, you can take it out. The main thing here I want to go over is example 1 and 2. So example 1 gives you the function, and it says solve for f inverse prime of 7. So I know the setup is 1 over f prime, f inverse of 7. This whole thing inside the parentheses means when y is 7, what is x? Okay, that's what it says. So looking at example 2, they give us the function. They want to solve for the derivative of f inverse of 3. Well, we know the setup is 1 over f prime, f inverse of 3. And this here means when y is 3, what is x? We can look at the table and spot it because we graphed the function in the table and looked at the table. And it says y equals 3, then x has to be 2. So this means we have 1 over f prime of 2. Well, when we get to this part, this is easy. We know how to get f prime. We know how to plug in 2. We just put 1 over that value. Okay? So now looking at the problems in our review, they gave you the function f is defined by f of x equals x to the third plus 4x plus 2. They say g is the inverse function. Okay? And g of 2 equals 0. So if they're inverses, right now, the values we have is 2 comma 0, but really in the original function, this was 0 comma 2 in the original function. Okay? 2 comma 0 is in the inverse. In the original function is 0 comma 2, so that's x comma y. Okay, so now we need to get g prime of 2. Well, that's the same as f inverse prime of 2. So I know the equation is 1 over f prime of f inverse of 2. Ready? So f inverse of 2 means when y is 2, what is x? Okay, well, we have that. It's right here. So x should be 0. I'm going to rewrite my formula, 1 over f prime of 0. When we get to this point, this is great because I know how to get f prime. Okay, f prime of x is 3x squared plus 4. Then I plug in 0. That's going to be 3 times 0 squared plus 4, which is 4. Then I take this number and put it in my fraction, and this is the derivative of the inverse function at 2. Okay, so this was the lesson that we had to do 2 days because it's a lot of back and forth steps, but you can definitely do it. Let me do another one. Let f be the function defined by f of x equals x to the third plus x. And again, if g of x is the inverse and g of 2 equals 1, then in the original function, we have 1 comma 2, which is x comma y. I need to know g prime of 2. In other words, f inverse prime of 2, which is 1 over f prime of f inverse of 2. This means when y is 2, what is x? We look at our point, x has to be 1. So I have 1 over f prime of 1. And at this point, this is great because I can get f prime of x, which is 3x squared plus 1. I can plug in 1, which is 3 times 1 squared plus 1, which is 3 plus 1, which is 4. So I have 1 over 4. So take a minute and pause. Make sure you're following through my steps. You can rewind when you need to. Make sure we're on the same page. Okay, number 28 says, let f be a differentiable function such that f of 3 equals 15, so that means 3 comma 15. F of 6 equals 3, that means 6 comma 3. And f prime of 3 equals negative 8. Well, this is a little different because this is for the derivative. It's 3 comma negative 8. And f prime of 6 equals negative 2. 6 comma negative 2. Okay, saying g is the inverse. G is the inverse. Great. So I need to know g prime of 3, which is f inverse prime of 3. And I know the formula, 1 over f prime f inverse of 3. Again, this means when y is 3, what is x? So I'm going to look for that. When y is 3, x is 6. Great, so I'm going to write that down. 1 over f prime of 6. F prime of 6. We know this. They gave it to us. It's right here. So we have 1 over negative 2. Okay, so make sure you pause, go back, make sure we're on the same page for this review. Okay, so you have a free response problem here. Take a minute to read the problem. The problem here says find g prime of 5, and you need to explain what this value means in the context of the problem. So you have a calculator, you can get the derivative of this function evaluated at 5. So I need you to do that. Now in terms of correct units, real quick, I need to write on the side that your calculator should be in radian mode. Radian mode. Now if you aren't sure how to do that, you can raise your hand. I can help you, but you need to make sure that your calculator is in radian mode. Okay, so for the units, okay, this is the derivative. And we know when we're talking about the derivative, it's the rate of change. So whether sometimes maybe it's increasing, maybe it's decreasing, depending on the value. If it's a negative value, then it's decreasing. If it's a positive value, then your rate of change is positive, which means the function is increasing. Okay. So once you get the value, you're going to say this value is the rate of g of t, which is the rate in tons per hour. Rate in tons per hour at which unprocessed gravel arrives. So that's tons per hour per hour. Okay? Some might say tons per hour squared. So this is the correct units. Make sure you check with the person beside you and the people around you to see that you guys all have the same value for g prime of 5. All right, I love these problems, the table problems, and I'm going to show you why. Take a minute to read the problem to yourself. Pause the video when you need. Okay, the problem says, use the data in the table to approximate C prime 3.5. Show the computations that lead to your answer and indicate units of measure. Now, this is the thing. C prime 3.5 means we need to take the derivative. Do we have a function to take the derivative of? No. So the next best thing is to approximate. And the way we do that, we have to think algebra, which goes back to the very beginning, which is slope. Okay? So slope is y, 2 minus y, 1 over x, 2 minus x1. Now this is the deal here. See 3.5? You should choose 2 points in this table that contains 3.5 in between them. So 0 and 1, nope. 1 and 2, nope. 2 and 3, nope. 3 and 4, yes. Because 3.5 is in between them. So I'm going to use these guys. So I have 3, 11.2 and 4, 12.8. Okay. I need you to take a moment because you cannot make a mistake when plugging this in. You're not going to get the right answer if you mix them up. So this is x1, y1, x2, y2. So I have 12.8 minus 11.2 over 4 minus 3. And then you solve. So this is 1 in the denominator. In the numerator, it's 0.6, 1.6. So I have 1.6. And the unit is you just divide top over bottom. The top was ounces. Bottom was minutes. So you do ounces per minute. Next one's very similar. Take a minute to read the entire thing. And it says, use the data in the table to estimate W prime of 12. Again, we don't have an equation here. We have to approximate. Hence, we have to use slope. Again, you have to contain 12 in between them. So 0 to 4, nope. 4 to 9, nope. 9 to 15, yes. So we're going to do 9, 61.8 and 15, 67.9. Again, that's x1, y1, x2, y2. Please use your formula appropriately. And then in the end, remember to put the units. It's very simple. The top is degree Fahrenheit. The bottom is minutes. So you should have your number with degree Fahrenheit over minutes as the unit. You can do this. Next one, again, very similar. So read the entire thing, and it says use the data in the table to approximate the rate at which a temperature of T is changing at T equals 3.5. So it's not going to be 0 to 2. It is going to be 2 to 5. So I have 2, 60 and 5, 52. And my units is degrees Celsius per minute. Next one, read the problem. And the units would be inches per minute. Make sure you check with the people around you and the person beside you that you guys are in agreement of how to solve this. Okay, so I'm going to pause right here. When you're ready, you can play the next video to go over piecewise functions.